Hello and welcome to the 7th video in the mathsonlinetuition.com videos going through the C1 book. We start with chapter 3, equations and inequalities. So the objectives here are solve the simultaneous equations by elimination and by substitution, and the final thing is solve linear and quadratic inequalities. Let's go straight into it. 3.1 solve simultaneous linear equations by elimination. Now, elimination, by its very definition, is to get rid of something, to eliminate. So it gives you an impression of what we're trying to do here. If we have 2x plus 3y equals 8, and 3x minus y equals 23, we can label this equation 1, equation 2. We use simultaneous equations, okay, when there are two unknowns. And in our case, it would be x and y, right? But also another reason for why we use elimination is because if we want to find the point of intersection. Imagine we have a graph here, okay? And we have two lines, right? We want to find this point of intersection. What are the coordinates? This is important to us because this is where these two lines, okay, will have the same x and y coordinates. And this is helpful for many reasons. But on a basic level, we can see, as is illustrated in this picture here, that we are trying to appreciate the coordinates in the sense that when we've drawn the linear equations, alright, can then get an impression of what the coordinates may be. Now, if you're using square paper like this, then obviously you can just spot it by looking at it. But what if we don't have very accurate square paper and we're using blank paper and we're not drawing it to scale, etc.? Then we have to figure this particular method out. So let's get straight into it. Now, there's many ways of tackling this. If you have 2x plus 3y equals 8 and 3x minus y equals 23, well, we can appreciate that the easiest thing for us to do would be the fewest or the least amount of steps, okay? So we can look at this particular equation 1 and this particular equation 2, and we can say, okay, if we want to get rid of x, well, we're going to have to multiply this and we're going to have to multiply that, which is totally possible and plausible. But how about just multiplying this particular equation by 3 so that we get the same number of a coefficient in front of an unknown and make life easier for us? So let's do that. So let's do 2 multiplied by 3. So we get 9x minus 3y equals 69. Alright, and then the next step we're going to do, that's step 1 you can say, step 2 is going to be 3, now this is equation 3, right, added to equation 1. So then this would give us, so we now have 9x, and then we can say, if we have 9x, let's write it out, minus 3y, 69, and then underneath it, truly like subtraction, we put 2x plus 3y, 8. So underneath here, okay, we're going to have 11x. Here we're going to have 0y, which is just equal to 0. And here we're going to have 77. Okay, so then this will tell us that 11x equals 77. And then again, we'll have that x equals 7. So then we can just simply put this back into the equation. So any one of the two will do. 2, 7 plus 3y equals 8. 14 plus 3y equals 8. If we take it to the other side, okay, 3y equals minus 6. So we'll have y equals minus 2. To double check that this is correct, how about we put it into the other equation, okay? Let's choose a different color, let's choose blue. So for example, let's say we have 3x, okay, minus y minus 2 equals 23. Now this is going to be plus 2 because of the two negatives. So we're going to have 3x, okay, 21. So this will give us x equals 7. So we've used different ways and different equations to get the same answer, which gives us that reassurance that it's correct. Okay, that's very simple, easy. Just a point to make here. If you've drawn a graph somewhat correctly in terms of its accuracy, okay, and you have a graph where the linear, where the lines, okay, cross one another like this, okay, and this is your point of intersection. Now, if you get something in your answer when you're working out, okay, some equation, if you get an answer that looks like x equals 5, okay, that's plausible. But if you get y equals minus something, and you look at this and you're sure that you've drawn it correctly, okay, then rethink your working out. You've gone wrong somewhere. And this picture again goes back to the importance of drawing or plotting the graph, okay, will give you help in the future. Now the final thing we're going to do for this video is substitution. In an exam you can be asked either one of the two, elimination or substitution, or sometimes it can even ask you to just solve it depending on which method you want to use. Now I always tell my students and I always tell people to master both techniques, don't get lax with one, okay? So substitution again, as is its definition, is to replace something by another entity. So you can imagine that when we're asked in this particular question, if we look at example 2 here, okay, example 2, to solve, so 2x minus y equals 1, 4x plus 2y equals minus 30. So let me ask you this question, okay? How do we substitute this? Right, well the best way for us to appreciate how to substitute is we've got two unknowns, okay? And the best thing that we want to do is get rid of one. So how do we do that? We want to make one of the unknowns a subject, okay, of its equation, right? So we have two choices. We can either use equation 1 or we can use equation 2. Looking at equation 2, we can see we've got relatively larger coefficient numbers than equation 1, so it could be fiddly and we might have to do other steps. But with equation 1, we can see that there's a y here compared to the x that has just 1 as its coefficient, so we don't need to do any division, so that makes life a lot easier for us. So we can have 2x minus 1 equals y. Again, you're just taking this there, taking that there. Right, then we can substitute this into 2. So what will then transpire is that we have 2x minus 1 equals minus 30. And now can you see how we have one unknown? The y has disappeared because we've substituted this into this equation. So then again, as normal, we just carry out our operations. Now expansion for x, okay, we have minus 2 equals minus 30, right? Again, we have 8x, takes to the other side, we have minus 28, and then as the answer suggests here, we're going to have a fraction, minus 3/2, which also equals 7/2, okay? Very simple, very straightforward. To figure out y, all we need to then do is put x back into the equation that has y as the subject. 2 minus 7/2 minus y. So we have this cancels out essentially. Minus 7 minus y equals minus 8. So we know that y equals minus 8, which is shown here. Okay? Very simple, very easy to do. So that's all for now with this particular video. You have examples here to carry out and do. It's up to you how many you want to do, but I would advise, if anything, perhaps try to use substitution here, but also elimination. And then also for the examples given above, try to do elimination but also substitution, and try to play around with both and get accustomed to both. So that's all for today's video, and then we'll go over some of the rest of the subsequent chapters as we progress through the book. Thank you very much for listening. Bye bye.